My name is Shah, and I'm an assistant professor at Northwestern University in the departments of Material Science and Engineering and Surgery. My lab primarily focuses on developing new functional materials for 3D printing using a printing platform of direct ink writing. We have printable hydrogel systems so that we can create complex organ and tissue systems. And then we also have what we call our particle-based inks, where we have the ability to print metals to ceramics to biological tissues.
One tissue type in particular that we're looking at is 3D printing an ovary bioprosthesis. This tissue target is really in need for young women who have gone through cancer and who have luckily beaten cancer, but cancer treatments have devastating side effects in terms of causing infertility and hormone inadequacies. So this artificial ovary, this ovary bioprosthesis, would be used to replace fertility and replace hormones for those young women.
Liver tissue engineering is particularly amenable to 3D printing. There is a current shortage of transplant donor organs, and as you may know, the liver has the capacity to regenerate. If you eat some kind of poison or something and knock out half of your liver, the other half will regenerate over the course of a few days. But there are certain chronic diseases like alcoholic fatty liver disease that will sort of slowly eat away the majority of your liver. And what we want to do is use this 3D printing technology to engineer a liver construct in vitro, implant that within a patient to regenerate the remaining liver.
With the 3D Bioplotter, I've really been able to focus on 3D printable materials development. The graphene work is quite interesting, and we're actually using this material to regenerate nerve tissue and muscle tissue in the coming future. So it's a very promising new biomaterial. It has great electrical conductivity, and it has great potential for non-biological applications as well, thinking for electronics and energy applications.
The major advantages of our particle-based inks is that we have the capacity to print any particle, so we don't need high temperatures or lasers to be able to 3D print an object that's made from metals or ceramics. So it really reduces the cost of metal printing.
The metal work is also quite interesting in that, similar to the graphene work, we're actually making a 3D printable metal ink. Now this ink is either made of metal particles, and those metal particles can be elemental, you think like iron, aluminum, nickel, or those metal particles can be alloys. Or in many cases, those metal particles can actually be not metals at all. They can be metal oxides. And so what we can really do is create any kind of metal oxide, metal, or alloy-based ink, 3D print it, and you get a final metallic structure at the end. So you really increase this materials palette, this 3D printable materials palette, whereby you can just swap out one cartridge, print metals and alloys, swap out another, print a material that regenerates nerve tissue or muscle tissue.
The ultimate objective and goal of my lab is to develop systems that end with 3D printed products that can be accessible to many people. That's important, especially in the biomedical realm, where cost makes a huge difference.
So this is truly the ultimate goal, and really 3D printing and additive manufacturing is to make a universal material method, and you can print anything you want.
It really lowers the cost, increases the complexity and versatility of what can be 3D printed, and the Bioplotter does allow us to be able to do that.